Hello, Science 9 students. This is Mrs. Arsenault coming to you from Screener with an animation and simulation that I found on the Learn Alberta website to help take us through some examples of different frames of reference. Frames of reference are very important to us for understanding how the initial models of the solar system and the universe were developed. The first example is actually going to be what we call a terrestrial linear example. So linear is just moving back and forth, and terrestrial means we're here on Earth. So this is a situation many of us have been in. We have two people standing on the sidewalk watching as a bus that contains a driver, a walking passenger, and a seated passenger drives by. And here's the bird's eye view. Here's our watching passengers, our spectators, our driver, our walking passenger, and our seated spectator or passenger. So if we press forward, what we're doing is looking at this view from the point of view of the people standing on the sidewalk. So as we watch, we can see everything driving past us. This means we are using the ground as our frame of reference. We are looking at what is moving in relation to the sidewalk. That is pretty straightforward. We're going to watch a different point of view now, which is from the point of view of the front of the bus looking backwards. Now what I want you to notice here is that the bus appears to be stationary and everything else is moving around it. So here's the passenger moving from the front to the back, and you'll notice how, I'm going to play it again. Watch the outside here. Watch how it appears that everything else is moving past. So we have everything moving past. Now if we take a look down here at the bird's eye view, again, it looks as though the bus is staying still and everything else is moving. So depending on what our frame of reference is, we will have a different point of view of what we are seeing. I'm going to give you one more example from Earth, which is terrestrial rotary, which is an example many of us have also experienced, which is just looking at a little merry-go-round. So the first point of view is taking a look from somebody sitting on the merry-go-round. This is where the camera is stationed. We can see that the merry-go-round itself looks stationary in relation to the camera. Everything else is moving. If the camera was moving in relation to the merry-go-round, we would see something different here. And you can see the bird's eye view. It looks as though the merry-go-round is stationary. We're going to take one more view, which is that of the ground. And of course, we can see now that in relation to the ground, the merry-go-round is moving. So this brings us to celestial motion. This is why we're here. Celestial motion is the movement of the sun, the earth, the moon, the stars, anything in the universe, essentially. So the first thing we are going to look at is the point of view of the night sky from the earth. This is what we see. This should not be unfamiliar to us. We are standing on the earth. Everything looks like it is moving. Now, if we look at the bird's eye view, we can see that that isn't the case at all, but we don't often get to have this view. And so we can see how initial models of the solar system had the Earth as the center and everything moving around it, because this is what we see. Now, if we take another point of view, this is above the North Pole. This is similar to that merry-go-round where we had the camera stationary in the merry-go-round or right above it. But we can see that it looks like the Earth is stationary. Now this can be a little bit confusing because it's hard to see how this can look stationary when it's actually moving. So I want to show you the next point of view, which is actually the camera above the Earth and not rotating. And you can see very clearly that all of the stars are staying still and the Earth is what is rotating. But if you're a person standing right here, what do you see? You see all the stars moving past you. This is why initial models of the universe had the Earth at the center. Now, if we actually jump two ahead, let's go back, I missed it. This is the view from far away from our solar system, and we can actually see that it looks like the Earth is moving back and forth when in fact it's going around. This is actually where Ptolemy's view of the epicycles came from. From Earth, it looks like this was happening with some of the planets. So, I hope that was a nice quick view. Please review it and we will do some activities in class. Enjoy!